Good evening, everyone. Myself Gautam Sharma. I welcome you all in a Sapience Education. So, for more information, please visit our website as well as contact us. So, here we will discuss about the current chapter, the current electricity. This is the part two video. I have already done part one video. So, there I have already discussed a lot. So, today I am going to discuss the Ohm's law and all. So, what is Ohm's law? Let us discuss Ohm's law. The current flowing through the conductor is directly proportional to the potential difference across it at a constant temperature. What do you mean by this? See here. Let us consider. Let us consider there is a conductor, right? And across this conductor, I am applying a voltage of V. Right? So, as per this Ohm's law, if current I is flowing, if you increase the voltage, so current will also increase. If you decrease the voltage, so current will also decrease. It means that current flowing across the conductor directly depends upon the voltage applied across it, right? But the thing is that the temperature should be constant, okay? And if you remove this proportionality constant, so I will get a constant term, and which is known as resistance, right? Resistance. And if you draw a curve, VI curve, if you draw a VI curve or IV curve, so you will get this slope, and this slope is known as resistance, right? See here, R is equal to what? R is equal to V by I. R is equal to V by I. So see here, if you want to find the current, so what will happen? This is the change in a voltage, and this is the amount of change in a current, right? Change in current. Okay. So from here, the slope indicates slope is equal to delta I by delta V. But I by V is your 1 by R. Okay. But if we draw the curve like this, V is to I, so what will happen? The slope indicates the resistance. See here, this is change in a voltage, and this is change in a current, right? This is change in a current. So here R is equal to delta V by delta I. So from here we can understood that the slope indicates the resistance. Slope indicates resistance, right? And here inverse of slope indicates the resistance. So resist 1 by R is equal to slope. Okay. Resistance R depends upon the nature, dimension, and the temperature of the conductor. Okay. So there are several factors in which the resistance also depends. First of all is the nature, which in nature either it is copper, either it is aluminum, either it is iron, and all. Another thing is the dimension. If the copper is like this and other copper is like this, so both have a different resistance because it both have a different dimension. And the temperature of the conductor, if the conductor, let us consider there is a two conductor of a same size and same material, but if its temperature is 100 degrees Celsius and its temperature is 30 degrees Celsius, so what will happen? The resistance at both the conductor will be differ. It means that conductor resistance depends upon the dimension, temperature as well as nature, right? So I hope you have understood this phenomena. So always remember these two types of a curve, that is VI curve and IV curve. IV curve, the slope gives the 1 by resistance, and in VI curves, gives you the resistance directly, right? So slope means what? Slopes, you have already studied in class 11. The slope is equal to this perpendicular divided by base. This amount, this length is known as slope. Okay. Resistivity rho depends upon the nature and material of the temperature. See here. What is electrical resistivity? First of all, see here. We have already discussed that R depends upon the dimension. R depends upon the dimension. Let us consider if one resistance is of this length L, and there is another resistance of same dimension, same cross sectional area, but length is 2L. So if this is R1 and if this is R2, then what will happen? R2 is greater than R1. Okay, R2 is greater than R1. I hope you have understood now. R2 is greater than R1. Why? Because if length is increasing, so resistance will increase. It means that resistance R is directly proportional to the length of the conductor. Another point is that if there is a conductor of a same length, but one conductor has a cross section, very thin cross section, and another conductor has a thick cross section. So if this is R1 and this is R2, so the resistance having less area has more resistance. It means that R2 is less than R1. It means that R resistance is inversely proportional to the area of the cross section. So when we combine this equation 1 as well as 2, so what will happen? We will get R is proportional to L by A, and if you remove the proportionality constant, so you will get the proportionality constant rho, and rho is called the nature of the material. Nature of material. Okay, so if L is equal to 1, area is equal to 1, so the amount of resistance offered will be equal to its resistivity. For example, there is a copper wire. It has a length of about 1 meter and the area of the cross section is 1 meter square, and this is a copper wire. So if you apply a current, so what will happen? Okay. See, if you apply a current, so you will get some resistance. So this amount of resistance is equal to its resistivity. Okay. Now, let us mm, discuss about which material has the more resistivity. See here, resistivity of the insulator is the maximum because it won't allow any type of a free electron to pass. Another, it uh, is alloy, semiconductor and conductor. So conductor has the least resistivity, but insulator has the more resistivity, right? And this is known as electrical resistivity. Now resistance, see here, it is up. The resistance can also be defined as it is a opposition offered by a conductor to the flow of electric current. So whenever electric current will flow, so it will oppose. That is known as a resistance. So we have already discussed this. R is directly proportional to length. We have already also discussed R is inversely proportional to area. When we combine this, so we will get the equation, and rho is known as the resistivity of the material or a specific resistance. Okay. Okay. A factor affecting the resistivity. So resistivity, we know that what type of factors affecting the resistivity. So as we know that Ohm's law, V is equal to IR, but we have already derived that what is I? I is your NEA drift velocity, right? So from here we can write like this. Now drift velocity, what is the value of drift velocity? It is E by M. We have already discussed this. Dip into tau by R. Now see here, in this side also there is V, in this side also there is V. Why? Because V is equal to IR, so R is equal to V by I, right? So here you can see that what is the value of electric field? Electric field is known as dV by dr. We have already discussed these things about in a previous class. That is your potential gradient. Potential gradient. So in place of electric field, we have written electric field. In place of dV, we have written V, and this is L. So when I will divide the E, so in place of E, I have written V by L. So V got cancelled out. So from here, if you want to find R, so R will be equal to M L by N E square A tau, right? So can you see here that M by n e square tau is the material property, and L and A is not a material property. And this m n e square by tau is known as resistivity because it is the material property. It depends upon the material property, right? Got it? Okay. So here we have finally got the relation, that is rho is equal to m, that is mass of electron into number of electrons into e square charge square by tau. So this is the material property. Okay. Now we have seen that just now we have derived m by n e square tau, m by n e square by tau, and this is equal to resistivity. So we have seen that resistivity is inversely proportional to n, that is number of electrons per unit, number of electrons, and tau is the relaxation time. Tau is the relaxation time, right? Now let us go for conductivity. What is conductivity? The inverse of resistivity is the conductivity. The more stronger is the resistance, less will be the conductivity. So if R is the resistance, so C will be the conductivity. So R is equal to 1 by C. So here the definition, the conductivity is the inverse of resistivity of a conductor is called conductivity, and since resistivity is denoted by rho, so conductivity will be denoted by sigma. So sigma by rho. So both are just inversely proportional. If more resistance will be there, so less conductivity will be there. If less resistance will be there, so more conductivity will be there. You can imagine that if there is less resistance, for conduction of the electrons or the conduction of the current will be easier. But if the resistance is very high, so what will happen? If resistance will be high, then what will happen? The conductance will be decreased, right? The SI unit is what? Ohm meter. Why ohm meter? See here, you need to understand. First of all, you have to understand that what is the unit of resistance. Unit of resistance. Okay. Unit of resistance. So the unit of resistance is ohm. Okay. So unit of resistance is ohm. And if you talk about the unit of resistivity, so R is equal to rho L by A we know. So from here, rho is equal to R into A by L. So R has a unit ohm, A has unit meter square by length is equal to meter. So meter square got cancelled out. So this will be ohm meter. So finally we can understand that the unit of resistivity, is the ohm meter, right? So from here we can understood that unit of the resistivity is ohm meter. Okay, unit of resistivity is ohm meter. Now conductivity we have already discussed. Conductivity is the inverse of the resistivity. So sigma is inverse of resistivity. So if you want to find the unit of the conductivity, so this will be 1 by ohm meter. So finally you will get ohm inverse meter inverse. Okay. So this is what about conductivity. Got it? Now the conductance. Conductance is the inverse of the resistance. Okay. So conductance is denoted by G and it is inverse of 1 by resistance. So if resistance is a unit of ohm, so conductance will be equal to 1 by ohm. And 1 by ohm means ohm inverse. Ohm inverse can also be written as moho. Moho, M-H-O, moho. Just as you remember like the OHM ohm, M-H moho. And you just reverse the symbol. Okay. So if you will reverse the symbols, then you will able to figure it out, right? Now, variation of a resistance or resistivity with the temperature. If resistance of the metallic conductor increase with the increase in a temperature, if you increase the temperature of the conductor, so what will happen? Its resistance will increase. Why? The increase in the temperature increase the amplitude of the vibration of a metallic atom, which cause some extra resistance in the path of a free electron. See, extra amplitude will be there. So what will happen? The metallic atom which cause some more extra resistance in the path of the free electron. See here, if electrons are going like this simply, but if another electrons are vibrating like this too much with the high amplitude, so what will happen? The collision amount of collision will be more. If amount of collision will be more, so what will happen? If amount of the collision will be more, then what will happen? Its resistance will increase because it unable to go, right? Now for a small temperature, see here, for a small temperature variation we will use this formula, very important formula. Try to understand what the formula is talking about. R is equal to R naught 1 plus alpha into T. What is R naught? R naught is R and R naught are resistance of a material at a temperature T and 0 degree Celsius. So at 0 degree Celsius resistance is this. So at a 30, 80, 40 degree, what will be the resistance? So we will use this formula. See here, R is the resistance at a 0 degree, alpha is the coefficient of the resistance, and the T is the temperature at which we want to find the resistance. Temperature at which we want to find the resistance. We want to find resistance. Okay. See what actually happens here. If you want to find the resistance of a body at a temperature of 100 degrees Celsius, so the resistance will be, let us consider R naught is the resistance given at a 0 degree Celsius. 1 plus alpha is also value, but temperature at which you want to find, so you should put the value. So you will get the final resistance at a temperature T, that is temperature at 100 degrees Celsius. I hope you all have understood now. Now see here, for a large temperature variation, see earlier what we have discussed, that if a small temperature will be variation will happen, then the resistance of conductor will be become R is equal to R naught 1 plus alpha T. But what about the large huge temperature difference? So if there is a huge temperature difference, let us consider the temperature is T1 and the final temperature is T2, and resistance at a temperature T1 is R1 and the resistance at a temperature T2 is R2. Now we know that R2 minus R1, that is difference in a resistance, is directly proportional to the amount of resistance initially it has, right? Also, if the temperature difference is large, so what will happen? Resistance change in a resistance will be also large. So it means that change in temperature is directly proportional to the change in a resistance, right? Now, also, if we combine this one as well as 2, so what we are getting? R2 minus R1 is directly proportional to R1 into T2 minus T1. Now, if you remove this proportionality constant, so what will happen? R2 minus R1 is equal to alpha R1 T2 minus T1. Okay. Now, if we rearrange this equation, so we will get R1 plus alpha R1 T2 minus T1. So finally, we are getting here R2 is equal to R1 1 plus alpha T2 minus T1. Okay. If the temperature difference is very large, so we should use this formula. So this is very important formula, right? Okay. Now, also in terms of the resistivity, we can write here that rho 2 is equal to rho 1, 1 plus alpha into T2 minus T1. Since resistivity will also change, since resistance is dependent on the temperature, resistivity is also dependent on the temperature. So resistivity, final resistivity can also be written as rho 1 1 plus alpha T2 minus T1, right? So here we can write directly, okay? Now one thing, for metals, alpha is positive. What do you mean by alpha is positive? Positive means what happens? If temperature will increase, so what will happen? Resistivity increases, okay? Now for alloy, what happens? For alloy, what happens? If temperature increases, so what will happen? Resistivity will also increase. Okay. But what about semiconductor? Semiconductor, what happens? If temperature increases, so what will happen? Resistivity will decrease. That's why it has alpha is negative, right? But here alpha is positive for semiconductor and electrolyte. For semiconductor and electrolyte. Electrolyte alpha is negative, right? Okay. I hope you have understood now. Now, what is superconductivity? In some metals or alloy, when the material is cooled to a critical temperature, that is minus 196 degrees Celsius, then its resistance will become zero. See here, let us consider at this temperature at 20 degree or any 1 degree, it has some resistance. But when you reduce the temperature to 196 degrees Celsius to minus 196 degrees Celsius, so the resistance will become zero. And this phase is known as superconductivity. This is known as superconductivity. Okay. Now in it is used for in a supercomputer. In supercomputer we required least amount of the resistance. In MRI scanner we also required least amount of resistance. So it is known as superconductivity. Okay. Now one thing we need to understand, if we want to stretch the wire, so what will happen? When conducting wire is stretched, its length increase, but the area of cross section will decrease. Definitely. If you stretch, so what will happen? Suppose this is initial length L and area is A1, then the final length will be L2 and the area will be A2. So the resistance will increases, but the volume remain constant. Volume remain constant, right? See here, volume will remain constant. So from here we can find that area into length will be equal to A2 into L2. See here, for this A1 L1 is the volume. Here also A2 L2 is the volume. So finally what happens? Volume will remain constant either initial as well as final. So from here A2 by A1 is equal to L1 by L2, right? So from here we can find, see here, R is equal to rho L by A. Rho L by A. See here again I'm just doing R is equal to rho L by A, right? Now, if I'm talking about R1, so R1 will be equal to rho into L1 by A1, R2 will be equal to rho into L2 by A2. If you divide both of them, so what we will get? We will get R1 by R2, and this is equal to rho get cancel out. So what we will get? L1 by L2 into A2 by A1. Now we have already derived that A2 by A1 is L1 by L2. So from here we can write here L1 by L2 is into L1 by L2. So from here we can get that L1 square by L2 square is equal to resistance ratio of the resistance. So this is very important derivation. Now we can also use this concept to find, see here L1 by L2, since L1 by L2, L1 by L2 is equal to A2 by A1. So we can put here like this, A2 by A1 whole square. Okay. So in this way, we can find the relation. So this will be very useful for solving the numerical. Okay. So I hope you have understood this session and you will, and I will also make a separate video for the numericals and the LCRT questions. So for being updated, you should always communicate with our channels. You should subscribe the channel so that you can get the regular updates. If you have any doubt, just you can directly connect with us so that I can figure out that what type of doubts are there. Okay, I hope you have understood now. Thanks for watching my video. Hope I will meet again. Thank you.